Volunteers are asked to measure heart rate both before and after consuming an energy drink. Researchers are interested in the effect of the drink on the heart rate. The following data are collected. So here's all of our people, and so this is the pre-drink heart rate and the post-drink heart rate. So we're looking for the effect of, does it appear that the drink had any effect on their heart rate? So tests a null that the energy drink has no effect on the heart rate versus the alternative, the energy drink does elevate the heart rate at the 1% significance level. So they gave us our alpha level. So we're saying the null is that energy drink, so no effect on heart rate. The alternative is that it elevated the heart rate. Now, symbolically, what would that be? So the mean difference is equal to 0, and the mean difference is greater than 0. So I'm going to be subtracting this with the post-drink minus the pre-drink. Now notice these are not two separate independent samples. These people are the same, right? These data come from the same people, right? So this is, this is my heart rate after, my heart rate before. So I'm only going to be doing a 1 sample t-test, not a 2 sample t-test, because these are not two separate independent samples. So I'm just going to be making a new list where I subtract out these from each other. And I'm going to be subtracting them, taking the post-drink and then subtract the pre-drink from it. So if it elevated the heart rate, then when I subtract these in that order, I should get positive numbers. All right, so what do we assume, right? So our assumptions, that we have an independent simple random sample, that there's no outliers, and that we have the normality assumption. Well, now we actually have the data here, so we can check these. So remember, here we've got an independent simple random sample. Well, we don't. We have volunteers. But we have to assume that these don't, that the fact that they're volunteers doesn't have any sort of impact on the outcome of the experiment. And it doesn't seem like it. Just because they're volunteering, it shouldn't change the effectiveness of the drug essentially on affecting the heart. So we have to assume that this is true. The no outliers, we can show that, right? We don't have to assume that now. So we can go stat, edit. There's the pre-drink, there's the post-drink, there's the difference. So I just subtracted, I just went L2 minus L1 and got the differences. Notice 108 minus 98 is 10, and 88 minus 85 is 3, etc. So here's my data that I'm interested in. So I'm going to go ahead and graph that, and I'm going to do a box and whisker plot to show that there's no outliers. And in fact, there aren't any. And it's relatively symmetric. I've got a little bit of skew here. So now I'm going to check my normality assumption. I feel pretty confident that's going to come out okay. And zoom 9. And yeah, it's not perfect, but it's pretty good. That's a fairly linear normal probability plot. So we can assume that the distribution of the differences is approximately normally distributed. Okay, so now we can just go stat, test. We're doing a t-test on the differences. So the null is that mu equals 0. We've got the data, so let's go there. The data is in list 3. Leave the frequency alone. We're checking to see whether the differences are positive, and we calculate it. And I got a t-score of 3.36. Notice if I go stat, calc, 1var stats on list 3, so I've got an average of 5.875. So let's just do our formula here. Our t-score is equal to 5.875, what we observed, minus what we expected, which is 0, divided by the standard deviation, which is going to be 4.94, divided by the square root of 8, since there were 8 volunteers. And this turns out to be, I forgot what it was. It was 3 point something, right? Stat, test, t-test, and 3.36, and the p-value is 0.006. So this is 3.36, and the probability that our t-score is as big or bigger than 3.36 is approximately 0.006. So what do we conclude? We reject the null. We do say that it does appear that the heart rates are elevated by the energy drink. So we reject the null. conclude the drink did elevate the heart rate.